Hi everyone, welcome back to Chem Help ASAP. Today we are going to be talking about scientific notation. Things that look like this. Is this a number? Is this a math problem? What is it? Let's find out.
Scientific notation consists of two parts. We have a number and we have 10 raised to some exponent. I want to first focus on the number. On my page, I have 4 different examples of scientific notation, and there are some similarities and there are some differences. The first similarity that I want you to notice is that there is one non-zero digit to the left of the decimal place. There is only one. There are not 2 digits, there are not 3 digits, and that digit cannot be a 0. It must be a non-zero number to the left of the decimal place. To the right of the decimal, we can have as many digits as our heart desires, and we may have zeros. So you can see in this first number, I have 2 digits to the right, then I have 1 digit to the right. Again, I have 1 digit to the right that happens to be a 0. And in this last example, I have 5 digits to the right, where 2 of them happen to be zeros. The important thing to remember about the digits to the right of the decimal place is they all must be significant figures. This is one of the fantastic things about scientific notation, is it eliminates all non-significant zeros. So how many significant figures in this first number? 1, 2, 3 significant figures. What about our second number? There are just 2. What about our third number? There are also 2. This 0 is automatically significant because it is part of the scientific notation. And our last number has 1, 2, 3, 4, 5, 6 significant figures. Now let's take a look at the second half of scientific notation. The exponent in scientific notation must be an integer. Now, it may be a positive or a negative integer, but it cannot be a decimal, and it also cannot be a fraction. So let's take a look at the positive exponents first, and then we'll talk about the negative exponents. Let's start with a problem you already know the answer to. What is 10 squared? Well, it's simply 100. So what if I have a scientific notation written like this, with 10 squared? Well, that simply means that you're going to take 7.91 and multiply by 100. That would give you 791. These two numbers are the same. Let's do the same thing, but now let's talk about 10 cubed. That, of course, is 1,000. So if I take the same 7.91 but now go to 10 cubed, I am simply going to multiply by 1,000 this time, which gives me 7,910. These two numbers are equal. This is why scientific notation can feel like a math problem. You are actually multiplying by a power of 10. Now, a disadvantage here is this 0 is not significant. In the scientific notation form, we had no trailing zeros. Those digits were all significant. But let's take a look at what happens with a negative exponent. This time, instead of having 10 squared, let's go 10 raised to the negative second. Now, a negative exponent just means you take the inverse. So 10 raised to the negative 2 is simply 1 over 10 squared, which of course is 1 over 100. So you can either think of this as multiplying by the fraction 1 over 100 or dividing by 100, whichever way makes the most sense to you. So looking at this number right here, raised to the negative 2, it is the same thing as saying I'm going to multiply by 1 over 10 squared, or dividing by 100, which is going to give me 0.0213. These numbers are equal, but just like we saw before, now we have leading zeros which are not significant. So we have added in zeros that are not significant. Now instead of doing 10 cubed, let's go 10 to the negative 3. That, of course, is the same thing as 1 over 10 cubed, which is the same thing as 1 over 1,000. Again, you can either think of it as multiplying by 1 over 1,000 or dividing by 1,000. So if I were to take this number raised to the negative 3, it's the same as multiplying by 1 over 10 cubed, or the same as dividing by 1,000, which gives me 0.00702. Again, these numbers are equal, but we have added in some leading zeros which are not significant. So let's summarize our rules for scientific notation. We always have one digit to the left of the decimal. This must be a non-zero digit. All of the numbers used in scientific notation are automatically significant figures. If the 10 is raised to a positive exponent, that is going to move the decimal to the right. If you have a negative exponent, that is going to move the decimal to the left. Again, you can also think of this as multiplying by a power of 10 versus dividing by a power of 10. What is the problem with our first example here? We have a 0 to the left of the decimal. That is not allowed. So how would we rewrite this in the correct form? We simply need to move that decimal place one space to the right. Here is correct scientific notation. What about this example here? What is the problem? Exactly. We have 2 digits to the left of the decimal. We can only have 1. So we need to move that decimal place one space to the left. Here is the correct scientific notation.
So I hope you found this video helpful and you have a little bit better understanding of what scientific notation is. But what is your opinion? Is it a number or is it a math problem? Let me know. Thanks so much for watching.